I did. So when answering the question, how many children will I have? The average value that we got, so on here is 1.57. Is that how many children you say that they have?
Well, in my case, I got 1.57. You probably got a different answer.
Yeah, so that's just like how many
So
children.
it's whatever your answer is for your simulation.
Okay.
But if you got 4, that's the wrong answer, because they can only have 3 children. Okay? So,
But how can we interpret, for example, mine? I have 1.9. So
1.9,
that's
yeah,
that's.
so you would expect they would have 1.9 children per family.
But how can you have 1.9?
Well, it's an average,
It's an average.
right?
Okay.
You got a bun in the oven, as they say.
Okay.
Okay?
How did you get that number though?
The
No,
average.
just leave it. Just leave it. The average.
This-
yeah, 'cause they say
No,
that
I
average
selected
American
all
has
the number of
2.3
children per family, and then I put equal average, and that's it.
So up to now, we've been talking about independent events. Independent, okay, means it, the outcome does not change based on previous outcomes. Okay, so if you have a girl, does the probability of having a boy, does that increase on the next child because you had a girl the first time? No, it's still 50%. Okay, so those would be independent events. If I get 4 heads in the row, does the probability of a head go up or down on the 5th try?
No.
No, that would be an independent event. Okay? Now let's talk about dependent events. I don't know if this is a good one. Okay? So, for dependent events, just like it sounds, it depends on the outcome. Okay? So, for example, for those of you who play cards, let's say that I pull a king. What's the probability that I pull a king out of a deck of cards? 4 out of 52. Okay? What's the probability that, okay, so if I pull a king out, okay, so I pull it out, what's the probability that I get a king on the second card?
3 out of 52.
It's 3 out of 51 because this card's been pulled out, right? So are these two events, are these independent or are they dependent?
Are dependent.
These are dependent events. The second card depends on what happened the first time. Okay, so this would be an example of a dependent event. Okay? So a lot of times with dependent events, this doesn't erase. Okay? We can use what's called a tree diagram. Okay, often used for dependent events. Okay? So let's say, for example, that you, unfortunately, are trying to decide if you want to get a new kidney. Let's say your kidney's failing, and you're trying to decide if you want to go through and get a new kidney. Okay? So let's say you talk to the doctor, and the doctor gives you some important statistics. Doctor says 90% of surgery patients survive surgery. Which means what? 10% are going to die on the table. Okay? Then he says, well, just because you make it through surgery, you're not out of the woods yet. Okay? The transplant succeeds 60% of the time, which means that 40% return to dialysis, which is why you wanted to get the surgery anyway, you were tired of that. Okay? But even after that, okay, those that live 5 years with the new kidney 70%. And those that live 5 years on dialysis are 50%. Okay, so the first thing I want to ask you is, do you think these two are independent events?
Wait, those that.
What does the 70% mean? Like if the 70%
So,
chance
so you go through, your transplant succeeds, okay? So sometimes when you go to get a new kidney, your body rejects the kidney. And so you have to get rid of it. So it succeeds 60% of the time, 40% of the time, the kidney doesn't work, you gotta go back to dialysis. Okay? So in this case, those that live 5 years with the new kidney are 70%. Those that live 5 years with dialysis is 50%. So are these events independent of each other? No. No, because what should they add up to if they were independent?
100.
They should add up to 100, and this adds up to 120. So these are not independent events.
If they add up to
They depend on
100,
the previous step, right? Another way to think about this is, those that live 5 years with the new kidney is 70%. What does that mean? What percent die? 30%. Those that live 5 years on dialysis is 50%. How many die?
50.
50%. So those cannot be independent of each other. Okay? Because they depend on the previous step. Okay? All right, so this kind of illustrates independence and dependence. Okay? All right, so here's what I'm going to do. Okay, so when you have dependent events, what you can do is you can do what's called a tree diagram. Okay, we're going to have to go upstairs to do the rest of this. Okay, so the tree diagram. So the first step is you're going to have surgery, right? What are the two outcomes for surgery?
Die or you don't.
You're going to live or you're going to die. Okay, what's the probability that you live?
50%.
It's 90%, right? This is 90%. Okay, you're probably going to make it through surgery. Your die is going to be 10%, right? We'll feel bad if you die, but as far as the math is concerned, we won't worry about you anymore. Okay? So now you make it through surgery. What are the two options after surgery?
There is a 60% of success.
It's going to succeed, or it's going to fail, which means you're back to dialysis. Okay? Well, I forgot to ask you the question here. The question is, what is the probability that you live 5 years? We're going to answer that question in just a minute. Okay? How you answer that is you're going to go through this. Okay, so the probability that it succeeds is
60.
0.60. Probability it fails?
0.40.
0.40. Okay? So if it succeeds, you have two options, and if it fails, you still have two options, right? What are the two options if it succeeds? You're going to live 5 years, or you're going to
Die.
die. And this one's got the same options, right? You're going to live 5, or you're going to die. Okay? All right, so the transplant succeeds. What's the probability that you live 5 years? 70. Probability you die? Probability you live? 50. Probability you die? 50. Okay? All right, so if we want to know what's the probability you live 5 years, there's two ways to get there, right? You can do the surgery, it will work, and you will live 5 years. Okay? So that's one way. So I've got 0.9 times 0.6 times 0.7. What does that equal? Who's got it?
It's 0.37.
0.37. Okay, so that's one option to get to 5 years. Okay? Now, the other option is, you're gonna do the surgery. It's not gonna work, but you're still gonna live 5 years. Right? Okay? So that's gonna be 0.9 times 0.4 times 0.5. What does that equal? 0.18? Okay, so you've got two ways to do that. You're gonna add them together and you're gonna get 0.558. Okay, so the interesting thing to look at here is, if you just look at this alone, probably that you live 5 years is 50% on dialysis. How much have you improved your probability of living? Just about less than 6%, right? Okay, so you have to ask yourself, is that surgery worth it? Now personally, I don't want to go to dialysis twice a week for the rest of my 5-year life. I think it would be worth it to me, not to have to sit there with a needle in my arm for how long did it take? 4 hours, whatever. It doesn't sound fun at all. So I would be willing to do it, but as far as improving your life, your lifespan, it's not going to improve it all that much. Okay? So anyway, that's an example of a tree diagram. I really wanted to show you that one more thing, but we're out of time for here. So when we get upstairs, I'm going to show you the March Madness. Should we do the quiz first? We'll do the quiz first, then we'll do the March Madness, because that's going to be extra credit, okay? Quiz first, and then we'll do the extra credit.